Welcome back, folks. In today's class, I'll continue talking about the circular motion and whatever concepts we've learned in the last class. Based on that, we're going to solve another problem. So we are given that there is a 0.98 kg of rock which is attached to a zero point 0.4 meters of a rope, and it's spun vertical direction. The tension on the rope when the rock is on top of the swing is 79 newtons down. So Ft is given to me, which is equal to 79.0 newtons down. And what is the speed of the rock? We are looking for the speed. So I'm going to write down the equation, and before writing down the equation, I'll draw the diagram. So the rock is moving in a circular direction when it is on top here. So what are the forces which are acting on this one? Because there is tension involved, so one of the force which is acting is downwards, that is Ft, and Fg we know that which always acts in the downward direction. So Fg is in the downward direction. So I'll write down the equation. Fc value will be equal to minus Ft and minus Fg, and this is equal to negative of Fc. Notice we won't consider the 9.81 as negative in this case because I've already taken the direction for the force. Now Fc value is equal to mv square upon r. This is negative, and this is Ft, which is negative 79 newtons, and minus Fg, which is 9.81 times the mass. Mass is 0.98 multiplied by 9.81. That's how I'm going to write it. And now if I were to do the math, then 9.81 multiplied by 0.98, that comes out to be negative 9.61, and this is negative 79. Down here I'll put in the value for mass. 0.98 multiplied by v square upon r, 0.4, and 79 plus 9.61, which is 88.61. And then I'll cross multiply 0.98. Let me first of all write down 0.4. This cross multiplies here, and then 0.998 will go down here, and I'll place the 1 so that you can actually understand. And now v square will be equal to 88.61 multiplied by zero point 0.4 divided by 0.98. So 88.61 multiplied by zero point 0.4 divided by 0.98, which will be 36.16 v square. 36.16 v square, and square root of v, which will be 36.16. Now v value will come out to be approximately 6 point something, so I will call it as 6.01 meters per second. That is the speed with which it will rotate. The rock will rotate in a circular direction. So hopefully you were able to understand the concept, how you can apply the equation. Now moving forward towards another concept, we can apply the same circular motion concept to the earth, how earth revolves around the sun, or how moon revolves around the earth. So if this is the sun and this is the earth which is moving along the uh, around the sun. So this is earth down here. So we're curious to know what's keeping the earth moving in a circular direction. So I'll like you guys to pause the video and think about it. Why earth is moving in a circular direction? Earth has a big mass. Why doesn't it distract from its path? And there is no friction also. Earth is not like a car which is moving in a circular direction on a road. So how does it keeps on moving around the sun? So pause the video and think about it for a second. So welcome back, folks. Hopefully you get a chance to think about it. So it's because of the gravitational force which we've learned in previous videos. That is Fg is equal to gm1 m2 divided by r square. That's the force which keeps them intact. Now again, the easier way I can understand is that I'm going to call it as Fc force, which is trying to pull it away from its path, and then Fg will keep it moving on its path. That's Fg. If these two forces are equal, as long as these two are equal, Earth will stay on its track. Earth will stay on its track. This is Fc and this is Fg. Again, that's an analogy which I'm using, but the reality is Fc always acts towards the center. Just by posing it in this way, I can actually make an equation easily and I can understand the equation easily. So uh, Fc is equal to Fg in this case, and thus Earth is staying on its path, and G value Fg value is Gm1 m2 divided by r square. I will call as m1 as the mass of Sun and m2 as the mass of Earth. Right. So and then this is Fc. We are trying to find the on the Earth, so I will consider centripetal force on Earth, m mv square upon r, and this is for Earth. So m2 was for Earth, so I'm going to replace here E and this as Sun. And now I can simplify the equation here. Mass of Earth, this cancels out, mass of Earth and mass of Earth. From here I can find out the speed with which Earth should rotate so that it keeps on rotating around the Sun. So Gms divided by r square, and then I will multiply this by r because there's one r down here which goes on top here, and I can cancel one of the r's, and then v value will be square root of G mass of Sun divided by r. So one thing we can notice in this formula is, if we wanted to find the speed with which any planet is moving across the other planet, I have to use the mass of the planet across which the other planet is rotating. So let's say this is Sun. I wanted to find out the speed at which Earth is rotating around the Sun. So I will be able to find the speed of Earth with which it is rotating by considering the mass of the Sun in this equation. Okay, I won't consider the mass of Earth in that scenario. So G mass of Sun divided by R. So in the same way, if I wanted to consider, let's say this is Earth, and then there is a planet which is revolving around the Earth. So I can find out the speed at which this planet should rotate around the Earth by considering the mass of the Earth. So V is equal to square root of Gm divided by R, and this will be the mass of Earth. Same case goes for the moon around the Earth also. So hopefully you were able to understand how we're going to put in the values in the given formulas. So based on this concept which we've learned, I'm going to try and simplify another question. So let's look into this question. A Landsat is a Earth imaging satellite that takes the picture of the Earth ozone layers and the geographical features. It orbits around the Earth at a height of 912 kilometers. What is the orbital speed and its period? So I'll just talk about the period down here also. What is a period? Period means the time taken to complete one cycle. So if the object starts from here, the time it will take to complete this one circular motion, that is called a cycle. And if I'm talking about the period, I'll talk about the frequency also. Frequency is the number of cycles in 1 second. That is the frequency. Okay. Now coming back to the question, so it is orbiting around the Earth at a distance of 912 kilometers. So this is down here, the Earth is. So I'm going to find out the speed, orbital speed with which the satellite should rotate so that it doesn't fall back onto the ground. So that will be equal to V equal to square root of G m divided by r. Which mass I'll consider? Mass of Earth down here. And then I'll put in the values and get the answer. G value, we know that this G is constant. 6.61 times 6.11, if I'm not mistaken. 6.11 times 10 raised to the power negative 11 multiplied by mass of the earth, which is 5.97 times 10 raised to the power 24. Let me verify it also. Yeah, so that's correct, but this value I've written it wrong down here. This is 6.67. 6.67 times 10 to the negative 11, and 5.97 times 10 to the 24. Some of the books use it as 5.98. Go ahead and use that value, whatever value. It's not going to make much of a difference, 98 or 97. So divided by r. Now that's important. How are we going to consider the r? To figure out the r, I have to find it from the center of earth to the center of satellite. But satellite is such a small object, so it doesn't make much of a difference. But earth's center from its surface is a huge distance, so I have to consider that distance for sure. That is 6.38 times 10 raised to the power 6 meters per second, and this one is equal to 912 kilometers. So I can call it as 912000, because 1 kilometer equal to 1000 meters. So 912,000 meters. So I'll add both of them. That will be the total distance. So this will be 912,000 plus 6.38 times 10 raised to the power 6. And then once you're gonna put in the values and you're gonna try and solve it, first of all, on the bottom you're gonna get 7.29, 7.2, oops, 7 point, oops, sorry guys. So you will get 7.29 times 10 raised to the power uh, 10 raised to the power 6 down here, and on top it is 6.67 times 10 raised to the power negative 11 multiplied by 5.97 times 10 raised to the power 20 24. And then once you're going to file these values in the calculator, that's where the students make a mistake. So if you're one of those students who like to file in everything in one go, so make sure you put a bracket here, start with the square root, first of all start with the square root and then a bracket, multiply these two together, close the bracket, then start another bracket, then close that bracket, and then you can find out the answer. But even with that, you have to, in some of the calculators you have to use two brackets here. So depending upon the calculator you have, because once you're going to put in the square root, this is what you wanted to show. So hopefully you understand how you're going to put these values in the calculator. So I'll show you. You'll press second function, square root, whatever your calculator says, start the bracket, another bracket, 6.67 times 10 raised to the power negative 11 multiply by 5.97 times 10 raised to the power times 10 raised to the power 24, close the bracket, divided by 7.29 times 10 raised to the power 6, close this bracket, and then close the other bracket. If your calculator doesn't start automatically, this bracket does. As I told you, you have to use the two brackets, and your final answer will come across as your final answer will be 7.39 times 10 raised to the power 3. 7.39 times 10 raised to the power 3, that will be the speed, meters per second. That's the speed with which the planet has to revolve around the earth so that it does not fall off from its position. Now I wanted to find the time. How can I find the time? So if we can recall the first previous lecture for the circular motion, what we said, that speed is equal to 2 pi r upon t. And now I wanted to find the time period, so I can move the time period on this side, and speed we have, we will move it down here. So time equal to 2 pi r upon v, and then we will finish this question. 2 times 3.14 multiply by the radius, not the radius, the distance we will consider. So distance is 7 point, the distance was 7.29, 7.29 times 10 raised to the power 6. I'm going to verify it one more time from the previously what we've written. Yeah, is what we've written down here. So divided by the speed is equal to 7.39 times 10 raised to the power 3. And then once you're going to do the calculation, you'll get the final answer as 6.20 times 10 raised to the power 3 seconds. 6.20 times 10 raised to the power 3 seconds equal to time. Again, in your calculator, make sure you use the brackets correctly. This in one bracket divided by this in the other bracket. Only then you're going to get the correct answer. So hopefully you were able to understand the question. Uh, and I'll see you with another videos. Till then, goodbye.